Hello guys, welcome back to Bimbel Publication. In this video, we are going to learn about the modulus function. So, what is modulus? Modulus of a number, or we say it's the absolute value, is the magnitude of a number without a sign attached. So, we just care about the size, how big is that number. If you put, for example, a positive number inside the modulus sign, it stays positive. Because we just care about the size, how big is that? Like, for example, 3 meter, how big it is? Oh, it's just 3. How long? Oh, it's 3 meters, so the size is 3. But if you put negative 3 or negative number inside the modulus sign, the result, the outcome will become positive. So any negative number you put inside the modulus sign will become positive. Because we just care about the size without a sign. So, for example, minus 3 meter means that you are moving to the left. How far? 3 meter. But the modulus means that we just care about the magnitude or the size, how far you go without caring about the sign or the direction. So it becomes 3 meter or just 3. If you put 0 inside the modulus, it will become 0. Same. Now, let's translate that definition into mathematical notation. So if you have absolute value of a number, let's say it's x, where x is a real number, you have two cases. The first one, the x will stay becomes x. Yeah, the modulus of x will stay becomes x without modulus. Yeah, if your x is positive or 0. If you look at the example, I put 3 becomes 3. I put 0 inside the modulus, still 0. That means x will stay x, given that x has to be greater equals to 0. But your absolute value of x will become minus x if your x is negative. So if your x, for example, minus 3, the output will become 3. You get it from minus of minus 3. X is minus 3. So minus 3 gives you 3. So putting negative here means that when x is negative, it will stay positive. Now, let's take a look at a more complex example, which is sketch the graph of y equals to 2x minus 1 in absolute value or modulus, and solve modulus of 2x minus 1 equals to 3. Now, we are going to use this definition first. Okay, so we have 2x minus 1. Yeah. Now, you have two cases. The first one, it stay become 2x minus 1 if your 2x minus 1 greater equals to 0. So if you look at the definition, it matches. X stays x, 2x minus 1 stay 2x minus 1 if your 2x minus 1 greater equals to 0. Or you can simplify, become x greater equals to half. Or it become minus of inside the modulus if 2x minus 1 less than 0 or x less than half. So you have two cases, yeah, and from these cases we can draw the function. So let's sketch the graph. Okay, let's sketch this first. 2x minus 1, the first case. Yeah, how do we sketch y equals to 2x minus 1? Well, it is a linear, so the shape will be a straight line. And then we can find the y-intercept and x-intercept by putting x is 0 and y is 0. When x is 0, y is minus 1. When y is 0, x is half. So the intersection will be x half and y minus 1. Okay, and then we draw the line. Okay, from here, let's draw the line. Okay, and then you may continue for now. Okay, this is purely y equals to 2x minus 1, not the absolute value of 2x minus 1. Okay, but we know that the domain for 2x minus 1 is greater equals to half. So x greater equals to half means that we take only the when x greater than half, which is we take the right part of the function. So it will not work if it is less than half. So that means you have to erase when it is less than half. Now, the second one, when x is less than half, the one that we just erased, it becomes minus of 2x minus 1. And when you learn in pure math 1 that minus of the function is just basically reflection over the x-axis. So, initially, your y-intercept is minus 1. But because you reflect that over the x-axis, it becomes x equals to 1. And then you just draw a straight line. Now, as you can see here, this is y equals to minus 2x minus 1 when x less than half. So if we draw the dashed line to represent 2x minus 1 graph, yeah, it's not a straight line. So like this, more or less. Okay. Now, this part, the negative part of the graph will be reflected over x-axis to become positive. Why? Because we know that when the value of x is negative, or the value of what inside the absolute value is negative, that means it becomes positive. So the output of the absolute value will always be positive. And by using this graph, we can also solve modulus of 2x minus y equals to 3. This is the y value, which is 3. So we can draw a straight line for y equals to 3. It's down here. Okay, let's move it down. Okay, and this is y equals to 3. So the value, the solution will be the intersection, which is 2 and minus 1. So the solution for this one is x equals to minus 1 or x equals to 2. So that is the solution. Now, let's learn about the absolute value equation. There are four types of absolute value equation you're going to learn in this video. So let's learn the first one. The first one is the simplest one. Absolute value of k equals to k, where k is positive or 0. Now, the result will be x equals to k or x equals to minus k. So let's look at the example then. So if you have x equals to, so value of x equals to 4, the result will be x equals to 4 or x equals to minus 4. This is the answer. Why is it like that? Because we know that if you put 4 in the absolute value, you'll get 4. If you put negative 4 in the absolute, you will get positive 4. So that means you have two solutions. Either you put 4 or minus 4 into the equation, you will get 4. But that will not work if you have this kind of equation. Absolute value of x, let's say it's plus 5 equals to 3. If you solve this, you get absolute value of x equals to minus 2. And this is no solution. Yeah. Does not mean that, oh, x equals to minus 2 or x equals to 2. No. This is no solution because first, the absolute value will always give you positive number. So there is no such number that gives you negative if you put modulus sign on it. So that's how you solve it. The second one, this is more complicated. Instead of having x in the modulus sign, we have a linear inside the modulus sign, like ax plus b equals to k, where k is greater equals to 0. Now, the solution will be the same. Yeah, either ax plus b equals to k or ax plus b equals to minus k, like before. So if you have absolute value of 2x minus 1 equals to 3, either 2x minus 1 equals to 3 or 2x minus 1 equals to minus 3. So from here, we can solve 2x equals to 4, x equals to 2, or 2x equals to minus 2, x equals to minus 1. So you have two solutions, which is 2 or minus 1, which is the same as before, minus 1 or 2, by solving using the graphic method. So either you can use graphic method or you can use algebra. Yeah, but if you have the graph already, maybe you can check using the graph. Third case is absolute value of ax plus b. Okay, it equals to not a number but another linear, cx plus d. So how do we solve it? First, it's the same as before. So ax plus b inside the modulus equals to cx plus d, or ax plus b equals to minus cx plus d. So same as before, either k or minus k, but for this case is either cx plus d or minus cx plus d. But you have one condition. Cx plus d has to be greater equals to 0. We know that the output of the modulus has to be positive. That means Cx plus d has to be greater or equals to 0. I'm going to use algebra method first, and then we can check it using graph method. Yeah. So absolute value of x minus 4 equals to 2x plus 1. So 2x plus 1 has to be greater equals to 0. So we get 2x greater equals to minus 1 or x greater equals to minus half. This is the requirement, and you have to follow the requirement. Yeah. Okay. Now let's solve for this. So there are two cases. Case 1 where x minus 1, sorry, x minus 4 equals to 2x minus 1, or case 2 where x minus 4 equals to minus in the bracket 2x plus 1. So this is one, this one should be plus 1. Yeah. So either equals to 2x plus 1 or minus 2x plus 1. So when you solve it, this one I got minus 5 equals to x. Case 2, I got x minus 4 equals to minus 2x minus 1. So I got 3x equals to 3. So I got x equals to 1. So we have two solutions here, x1 or minus 5, but you have to check the requirement. The requirement is x greater equals to minus half. So we just have one solution, which is x equals to 1. Okay, now let's use graph method to show that there is only one solution, which is x equals to 1. So let's sketch 2x plus 1 first, the easiest one. So y equals to 2x plus 1. So when x is 0, y is 1. When y is 0, x is minus half. So we got minus half is around here, and y equals to 1, it's around here, and then you take a straight line. Okay, this is 2x plus 1. Now, we also want to sketch the absolute value of x minus 4. So it will become x minus 4 when x greater equals to 4, or x minus 4 when x less than 4. So from here, we can sketch x minus 4 first. So when y is 0, so let's put here y equals to x minus 4. So when x is 0, y is minus 4. When y is 0, x equals to 4. So we have x equals to 4 is around here. And y is minus 4. So it's around here. So we take the line is around here. But we know that the negative part of the graph will be reflected over the x-axis. So instead of having minus 4, you get 4 over here. And then you sketch it. Wait, it's not. It's like a curve. Wait. Okay, so it's around here. Now, as you can see, it only intersects once, and it is when x equals to 1. So we only have one solution, which is x equals to 1. When it is minus 5, as you can see, this is minus 5, it does not intersect, right? So this one going up, this one going down. So you only have one intersect. But there might be a case where you don't have intersection at all. For example, I have a line like this, no intersection, right? Like they are parallel to the line. Or you have two intersection, maybe like this. You have two solution. So be careful. You may have two solution or one solution, for example, like this, or no solution at all by checking the condition. Okay, guys, let's learn the fourth example. In the fourth example, we have two absolute value in both sides. So how do we solve this kind of question? First, we can use the first method, which is the same as method number 3, method 2 and 1, yeah, where we put the ax plus b equals to minus cx plus d, or ax plus b equals to minus cx plus d, same as the previous example. Or method 2, where we can square both sides. And we know that we can square both sides if we know that both of them are positive. Yeah. So for example, absolute value of a equals to absolute value of b, and you can square both sides, become a square equals to b square. Well, you can do method 2 to solve the previous example, which is example 3, but you have to be careful with the requirement here. Yeah. So you should always put requirement here. And method 3 is graph method, and you can just do it for your self-practice. Now, let's take a look at the example taken from past paper, and I'm going to do method 1 and 2 only. So using method 1, the x minus 2 equals to 1 over 3x, or x minus 2 equals to minus 1 over 3x. This one is easy, you just solve it. You got 2 over 3x equals to 2, or x equals to 3. This one you got 4 over 3x equals to 2, so x equals to 3 over 2. And there is no condition like before, because before the cx plus d can be positive or negative, but for this one, we know that it's always positive because we have absolute value sign. Method 2, we square both sides. Yeah, because both of them are positive, we can square both sides. Yeah, so we can square both sides, become x minus 2 square equals to 1 over 3x square. So I got x square minus 4x plus 4 equals to 1 over 9x square. From here, we can multiply by 9 to eliminate the fraction. So I got 9x square minus 36x plus 36 equals to x square. From here, we have 8x square minus 36x plus 36 equals to 0. From here, we can just factorize, or maybe I can just divide by 4 first. So I got 2x squared minus 9x plus 9. So to make it easier for me to factorize, so when I factorize, when I factorize, I got 2x and x, and I have 9, so 3 and 3. This one is 6x, this one is 3x to get minus 9x, so I put this, so I got this. So that means we have x equals to 3 over 2, or x equals to 3. And when you graph it, you will get exactly 2 solutions without having any constriction like before. So you can choose method 1 or method 2 or even method 3. You just graph it, but it takes time. Another example, when you have more complex example, for example, you have absolute value of x plus 3 plus absolute value of x plus 5 equals to 10. So how do we solve this kind of problem? First, we can isolate one of the absolute value. So when you isolate, it becomes x plus 3 equals to 10 minus absolute value of x minus 5. And we apply the first method. Yeah, you have two cases. Case 1, where the x plus 3, the inside the modulus, equals to the right side, where the inside the modulus equals to the negative of the right hand side, which is x plus 5 modulus minus 10. So we use the first method. And then from here, I can once again simplify and isolate the modulus. So I got x plus 5 equals to 10 minus x minus 3, which is just equals to 7 minus x. And from the case 1, I have another case. This is another modulus. So from here, I got either the inside the modulus equals to right hand side, or the modulus inside equals to the negative of the right hand side, become x minus 7. So when you solve it, the first one I got 2x equals to 2, so I got x equals to 1. So this is my first solution. The second one, this one is a little bit weird because when you cross out the x, you get 5 equals to minus 7, so I got no solution from here. Move on to case 2. Yeah, I isolate the modulus sign. So I got x plus 13. So once again, I have another case, two cases from case 2. The first case where the x plus 5 equals to x plus 13, or x plus 5 equals to minus x minus 13. So the first one, once again, I got a weird result, 5 equals to 13, which is no solution. The second one, I got 2x equals to minus 18, so x equals to minus 9. So from here, we have two solutions, x equals to 1 or x equals to minus 9. In the next video, we are going to learn about the modulus inequality, so you can watch the next video. Thank you.